Imagine a cold, dark world drifting through the cosmos, untethered to any star. This is a rogue planet, an eerie wanderer of space, untied from the gravitational embrace from its star. In the far future, humanity has extended its reach to the fringes of our solar system, mining asteroids and comets for precious resources. But when a rogue planet enters the solar system, everything changes. Unexpectedly caught in the rogue planet's gravity, a commercial mining vessel is damaged by cometary debris. The crew makes an emergency landing, bracing as they fall toward an unseen world racing out of the interstellar darkness. Rogue planets, like the one our expedition has encountered, are free-floating bodies that have been ejected from their original systems. Without a star, they drift through space in perpetual darkness and extreme cold.
You're going to give us some facts about rogue planets disguised as a science fiction story, aren't you?
Why, yes, Steph, I am. Let's engage.
Take your seat. The human adventure is just beginning.
Unlike the planets in our solar system, which orbit the sun in well-defined paths, rogue planets drift freely through the vast expanse of space. These nomadic worlds have typically been ejected from their original planetary systems due to intense gravitational interactions, whether with other planets or passing stars. This ejection can occur during the chaotic early stages of a solar system's formation, or even later in a planet's life when gravitational disturbances from nearby celestial objects disrupt its stable orbit. As a result, rogue planets become solitary travelers, navigating the cosmos in perpetual darkness. One of the most intriguing aspects of rogue planets is their sheer diversity. While some rogue planets are massive with sizes comparable to or exceeding that of Jupiter, the majority are likely to be much smaller, Earth-sized, or even smaller than that. These small rogue planets present a unique challenge for astronomers. Detecting an Earth-sized rogue planet is incredibly difficult because without a host star, they emit little to no light of their own. Traditional methods of planet detection, such as observing the dimming of a star's light as a planet transits in front of it, are ineffective for these solitary wanderers. Instead, scientists rely on techniques like gravitational microlensing, which involves detecting the slight bending of light from distant stars as a rogue planet passes in front of them. However, this method requires precise alignment and only provides fleeting glimpses of these elusive worlds. Given the limitations of detection, it's entirely possible that Earth-sized rogue planets could remain hidden until they venture into the outer reaches of our solar system. By the time such a planet becomes noticeable, it might already be causing gravitational disturbances in the distant regions where comets and other small bodies reside. For humanity, this means that a rogue planet could slip past our astronomers unnoticed until it begins to influence the orbits of objects in the Kuiper belt or the Oort cloud. At this stage, the rogue planet's presence might be inferred through irregular movements of these icy bodies, but direct observation could still be challenging due to the vast distances and the planet's dimness. Yes, an Earth-sized rogue planet could enter our solar system almost undetected, giving us little warning before it starts to alter the delicate gravitational balance that keeps our planetary neighborhood stable. While the likelihood of this scenario is extremely low, understanding the characteristics and behaviors of rogue planets helps astronomers assess potential risks and expand our knowledge of planetary dynamics. Additionally, studying rogue planets offers valuable insights into the formation and evolution of planetary systems, revealing the hidden stories of worlds that once orbited stars but are now solitary travelers in the dark void of space. As our detection methods continue to improve, we may soon uncover more about these mysterious wanderers and their place in the universe.
What's happening with that expedition?
Captain Elias Marlowe stands at the helm of the comet mining vessel Pioneer, his weathered face illuminated by the soft glow of the control panels. His crew, a tight-knit group of seasoned miners and engineers, respect his decades of skill and unwavering dedication. He has always kept them safe and on mission, Now, as the Pioneer drifts through the silent expanse, a new threat emerges: a rogue planet, massive and unforgiving, hurtling toward their position with terrifying speed. The first impact is swift and brutal. Alarms blare as the rogue planet's gravitational forces stir up debris to hammer the ship's engines, leaving the Pioneer crippled and adrift. Panic flickers in the eyes of the crew. The ship's young radio officer, Jalen Cade, quickly determines that the communications array has been damaged beyond repair. No SOS can be sent. Captain Marlowe remains resolute. He assesses their limited options. Returning to base is impossible, and with their main engines damaged, the vast unknown of the rogue planet looms ahead. Gathering his crew on the command deck, he knows that fear could either paralyze them or propel them into the annals of history. The captain turns, his gaze sweeping over the anxious faces before him. Taking a deep breath, Marlowe begins, "We've spent much of our lives out here, alone in the dark, far from home. But today, we have a chance to make our mark in a way we never imagined. This rogue planet, it's more than just a threat. It's an opportunity. An opportunity to be the first humans to set foot in an uncharted world, to explore its mysteries, and to push boundaries of what we know." He pauses, letting his words sink in. Then he continues with a fervor that ignites the room. "Think of the explorers before us, those who dared to sail into the unknown, driven by curiosity and the spirit of discovery. Today we stand on the brink of our own odyssey. Let us embrace this challenge with courage and determination. Together, we will land on this alien place not just as miners, but as pioneers, befitting the name of our craft, explorers of a new chapter in human history. This is our moment to shine, to show all humankind what we are capable of. Let's make it count." Inspired by their captain's word, the crew feels a surge of determination. Hurried repairs bring the ship into landing condition as the rogue planet's gravity pulls them down. Pioneer's landing thrusters engage, and with synchronized precision, the ship begins its descent onto the rogue planet's icy surface. As the vessel touches down, the collective breath of the crew is released in unison. They are no longer just miners stranded in space. They are the first humans to explore a world untethered from any star, embarking on a journey that will forever change their lives and expand the horizons of human exploration. But how long can they survive? The first compelling evidence for the existence of rogue planets emerged in the early 21st century. Isolated planetary mass objects, or IPMOs, were first discovered in 2000 by the UK team of Lucas and Roche using the UK Infrared Telescope. Their trapezium cluster in the Orion Nebula turned up 13 objects below the brown dwarf threshold, with the smallest only about 8 Jupiters in mass. The smallest rogue planet ever discovered is OGLE 2016 BLG 1928. Which is estimated to be between the size of Mars and Earth. Astronomers discovered it using the Warsaw Telescope at Las Campanas Observatory in Chile. The discovery of rogue planets has been made possible through advancements in astronomical techniques and the deployment of sophisticated satellites. One of the primary methods used to detect these elusive worlds is gravitational microlensing. This technique relies on the bending of light from a distant star when a rogue planet passes between the star and Earth. The planet's gravity acts like a lens, magnifying and distorting the light in a detectable way. The microlensing observations in astrophysics, or MOA survey, and the optical gravitational lensing experiment, or OGLA, have been instrumental in identifying rogue planets using this method. Additionally, space telescopes like the Spitzer Space Telescope and the James Webb Space Telescope, JWST, have enhanced our ability to observe these planets by providing high-resolution images and more precise data on their properties and movements. Some of these objects are theorized to have formed directly from the collapse of a gas cloud without any star formation involved. Contrary to the notion that rogue planets move entirely randomly, their paths are often governed by the gravitational forces exerted by stars, black holes, and other massive entities in the galaxy. This means that over millions or even billions of years, rogue planets can maintain relatively stable orbits within certain regions of the galaxy, slowly drifting through space while retaining internal heat from their formation. The longevity of rogue planets is another area of keen scientific interest. Without the external heat and light from a star, rogue planets must rely on internal sources of warmth to maintain any habitable conditions. Many rogue planets are believed to retain significant internal heat generated during their formation, as well as residual heat from radioactive decay within their cores. This internal heat can keep subsurface oceans liquid for billions of years, potentially providing environments where life could exist independently of a host star. Theoretical models suggest that some rogue planets could remain geologically active for up to about 10 billion years, even outlasting the lifespans of the stars they were once associated with. This extended period of internal warmth opens up intriguing possibilities for the existence of life in extreme and isolated environments, expanding our understanding of where life might thrive in the universe. A popular hypothesis related to rogue planets involves the formation of our moon. The Theia impact hypothesis posits a Mars-sized body named Theia colliding with the early Earth, leading to the formation of the moon. Theia was not classified as a rogue planet in this context, since it was still a part of the nascent solar system, but the idea underscores the significant role gravitational interactions and collisions play in shaping planetary systems. While their trajectories may be influenced by gravitational forces, allowing for some predictability, rogue planets continue to wander the galaxy, their internal heat sources offering a glimmer of hope for potential habitability. The study of rogue planets not only broadens our understanding of the cosmos, but also invites us to ponder the myriad possibilities of life beyond the confines of starbound worlds. As the Pioneer settles onto the icy terrain of Nyx, named by the crew after the Greek goddess of night, the crew becomes filled with equal parts dread and wonder. What does the arrival of this rogue world mean for their survival, and for Earth's too? If they are to survive, they will have to have answers. Captain Marlowe continues to rally his crew, paying special attention to Jalen Cade. The young comms officer has worked tirelessly to repair their transmission array and blames himself for every delay and failure. Marlowe does his best to turn grim circumstance into the hopeful persistence they will need to survive, telling Jalen, "Our skills and determination are all we have, even when things seem impossible. Your work on the comms is vital, and every delay, every failure is just another step toward finding a fix, a way to let the world know what's become of us. This planet is a symbol of the unknown, of what lies beyond our comfort zones. Embrace that. It's what makes each of our days here meaningful and keeps us going." "I'm out of ideas," Jalen confesses. I've scrounged everything but the circuit boards from the aeroponics bay. If I do that, we'll starve faster." "I have an idea on that," Marlowe answers. "We saw water plumes on the way down. The lab detected organic compounds in the spray. There's an inactive plume not far from here. Remember the Europa bass they found living around the thermal vents on Jupiter's moon? Something like that might keep us going. How about I put you on the drilling crew for a while? Give your mind some rest on the comms issue. With luck, we may yet be able to get those circuit boards for you from the aeroponics." Beyond their ship and the mining transport they deploy, the surface is a stark, desolate landscape of frozen plains and jagged ice formations. The crew overcomes basic survival challenges in good order, purifying water liberated from subsurface eruptions, ensuring a steady supply of oxygen from the frozen atmosphere and the water ice all around. They can even separate out hydrogen for fuel and plan the necessary repairs to the main engines. An experienced mining team, they are expert at drilling under the most challenging conditions, and cutting deep into the rogue world's icy shell gives them geothermal power and may just find them a source of sustenance too.
You mean a rogue planet might have an entire ecosystem inside it, beneath the frozen surface?
It's a concept that really captures the imagination, doesn't it? I believe you could have an Earth-like rogue planet where heat from the core keeps the world warm and alive beneath its frozen surface. Massive hydrothermal vents akin to Earth's black smokers spew mineral-rich, superheated water from the planet's mantle, creating oases of warmth and chemical nutrients in an otherwise frigid and inhospitable environment. The heat from these vents could sustain a unique ecosystem where life thrives without the need for sunlight, instead harnessing chemical energy through chemosynthesis. The constant ebb and flow of vent emissions would create dynamic environments, fostering a diversity of habitats and niches for various organisms to exploit. At the heart of such an ecosystem would be chemosynthetic microorganisms, both bacteria and archaea, that form the foundation of the food web. These organisms convert hydrogen sulfide and methane abundant in geothermal vent emissions into organic molecules, providing the essential energy source for the entire community.
A life cycle with no sun to power it.
Clusters of microbes create biofilms around the thermal vents, serving as the primary producers that support a myriad of other life forms. In addition to bacteria, specialized algae-like organisms adapted to low-light conditions perform a similar role, further enriching the ecosystem's base. These primary producers are the lifeblood of the hidden ocean, enabling a complex and self-sustaining food chain to develop in the absence of sunlight. Supporting the microbial foundation are a variety of consumers, each uniquely adapted to such a dark and extreme environment. Transparent, gelatinous creatures resembling Earth's comb jellies might drift gracefully through the water, feeding on the abundant microbial life. Larger, predatory organisms with bioluminescent features could patrol the depths, using light to attract prey or communicate with one another. These predators might evolve enhanced sensory organs to navigate the perpetual darkness, relying on vibrations and chemical signals to locate food. Symbiotic relationships are prevalent. For instance, certain predatory species host bioluminescent bacteria on their bodies, which provide illumination in exchange for nutrients. This mutualism enhances their survival and adds a mesmerizing glow to the underwater landscape. The ecosystem's complexity is enriched by specialized niches created by varying vent activity and chemical compositions. In areas with more intense geothermal activity, diverse communities flourish around clusters of vents, each harboring distinct species adapted to specific chemical gradients. Some organisms have developed unique biochemical pathways to exploit rare minerals or extreme temperatures, pushing the boundaries of known life forms. Additionally, the stability provided by these geothermal hotspots allows for long-term evolutionary processes, potentially leading to the emergence of highly specialized and even intelligent life forms.
We're about to meet the aliens of Nyx, aren't we?
And this is where we really put your willing suspension of disbelief to the test. Beneath the thick, icy shell of Nyx, an advanced civilization thrives in perpetual darkness, having adapted ingeniously to their planet's harsh, sunless environment. Originally flourishing within the habitable zone of their star, the inhabitants of Nyx were a highly intelligent and industrious species with a sophisticated technical society. When gravitational upheavals ejected Nyx from its solar system, the Nyxians faced an existential crisis. Using advanced engineering and leveraging geothermal energy, they constructed subterranean cities around the planet's vast network of hydrothermal vents. These geothermal hotspots provide the essential heat and energy needed to sustain their society, empowering everything from life support systems to intricate technological advancement. Over generations, the Nyxians developed bioluminescent lighting and energy-efficient infrastructure, ensuring their cities remain vibrant and functional despite the icy exterior of their planet. To manage their waste products and dissipate excess heat, the Nyxians devised a remarkable system utilizing the plumes of water that periodically erupt from Nyx's surface. These hydrothermal plumes, rich in minerals and heated by the planet's internal forces, serve as natural conduits for environmental management. The Nyxians channel their industrial byproducts and waste heat into these plumes through a network of subterranean pipes and filtration systems. This method not only prevents the buildup of harmful substances within their cities, but also harnesses the natural energy flow of Nyx to maintain environmental balance. The Nyxian civilization exemplifies resilience and adaptability. Just like the Earth crew of Pioneer, they have transformed a potential catastrophe into an opportunity for sustainable survival and continuous advancement. And the landing of Pioneer has not gone unnoticed. Rather, the drilling of the Pioneer mining team has caught the curious attention of a Nyxian hydrothermal engineer named Vetus. It's not long before this subterranean engineer recognizes the sound of intelligent activity. Someone is drilling on the surface. She is sure of it. In Nyxian lore, these scattered survivors who tried to remain on the surface just as other civilizations might establish a base on a moon or an airless world. All contact was lost long ago, thousands of years ago. But could this newly detected activity be the latest generation of surface survivors trying to make contact with their more successful cousins beneath the ice? Vetus sounds the alert. On the drilling team, Jalen is a junior cross-trained hand. When they encounter unexpected vibrations, the team leader is ready to break down the rig and move on. The possibility of a plume erupting beneath them is both dangerous and real. But Jalen recognizes something the others do not: an unnatural modulation in the interference coming up the shaft. These are signals, basic attention-getting signals, and the crew needs to respond. Over the next few days, the atmosphere aboard the Pioneer is charged with a mixture of anticipation and tension. Jalen takes the lead in establishing a simple, signal form of communication with the intelligence below. Vetus, for her part, organizes the work to create a vertical tunnel that will link those on the surface with the subterranean civilizations of Nyx. The task is daunting, drilling through miles of ice while ensuring the structural integrity of both the Pioneer and the Nyxian infrastructure. Human and Nyxian crews work around the clock, their efforts synchronized in a delicate dance of human ingenuity and alien technology. With no way to translate languages so quickly, Jalen pushes both sides to use the universal language of maths, and the figures tell the tale. We need to stabilize the core temperature and atmospheric pressure around the drilling site, he explains, pointing to the holographic display from Vetus that maps out the tunnel's trajectory. If we fail, the entire structure could collapse, severing any chance of meeting our friends below. Supporting Jalen as best they can, the drilling team devises a cooling system that prevents the ices from fracturing under the immense pressure and heat generated by the drills. Finally, the day arrives when the tunnel is complete. Rising in the vertical shaft, a silver teardrop shape moves toward the surface. Within the craft, Vetus and her crew excitedly await the moment they will meet with survivors of an ancestral catastrophe. Little do they know that their world has entered a new solar system, and that the creatures awaiting them are unlike any they can imagine. For his part, Jalen Cade smiles and holds up his hand in greeting. From the strength and modulation of the signals emanating from the silver craft as it breaches the surface, he knows the Pioneer will soon be able to repair its transmitter and to tell its story to the entire human world.
Phew, I'm glad they made it. How likely is a story such as that?
Well, Def, not very likely. But through the eyes of the Pioneer crew, we've learned a lot about rogue planets. By some real estimates, there could be 4 trillion rogue planets in the Milky Way alone. That's a lot of stories out there. Who's to say a tale like we've told today hasn't happened somewhere out there in the cold and vasty dark?
Bye-bye for now.
Hey, Dreamforge Magazine is a science and fantasy fiction magazine founded on the idea that the human adventure is just beginning. Our stories aren't about apocalypse, doom-scrolling, or dystopia. Speculative fiction should be the literature of hope, genius, determination, and ideas. And that's what you'll find in our homes. We often use the tagline, "In all worlds and times, our tales revolve around those individuals and groups who bring meaning and value to the world, whose actions are of consequence, and whose dreams are the vanguard of things to come." If you love science fiction and fantasy, don't miss out. Support us at the digital or print level on Patreon or at our website. Links will be in the description. A few dollars a month from you helps bring great stories to life.
Until next time, bye-bye.